If you're in the business of building IoT solutions, devices, connecting them to the cloud, you'll be interested into watching this IoT show episode with Stefan Vick, who was telling us everything you need to know about IoT plug and play and how to add the plug and play magic to your IoT solutions. Today on the IoT show. Hi everyone, this is the IoT Show. I'm Olivier, your host, and today we'll talk IoT plug and play. And we have Stefan Vick from the Azure IoT Developers and Devices team. Stefan, thanks for joining the show today.
Hello, Olivier. Thanks for having me. Pleasure to be here.
Before we jump into the topic, Stefan, and we'll see tons of demos today. Love it. Really looking forward to it. Tell us a little bit about yourself and what you're doing at Microsoft with your team.
Yeah. I'm a lead program manager at Microsoft. I've been at Microsoft actually for 20 years now, working on different developer technologies. And right now I'm leading the developers and devices group in the Azure IoT team.
Awesome. So we've been talking about IoT plug and play, which is a very nice feature that we're proposing to developers, both for solution developers and device developers. So we've been talking about that a little, but a little refresh and reminder for people, what is IoT plug and play?
Yeah, IoT plug and play is a new technology that we're releasing a new preview today with IoT plug and play. Device builders and solution builders can eliminate the tight coupling between the devices and the solutions very easily, and take advantage of a large ecosystem of both cloud solutions as well as IoT devices. So if you look at the problems today with IoT, we see there is this tight coupling between the software on devices and in the cloud. And this often means, as a cloud solution developer, you have to get involved in device development and vice versa. So we've had these challenges in the past as well. If you think about, way back in the 90s, if you wanted to connect a peripheral like a keyboard or a mouse to your PC, it was actually quite a difficult exercise, because it didn't just work. You had to install a particular driver, do some configuration, and then if you're lucky, it worked. And then at some point, Windows introduced plug and play, which basically enabled the peripheral to announce its capability model on connection. So the operating system then knew what kind of device it is, and what type of interaction it supports. And so that was a great step forward in the PC ecosystem at the time. And so what we're doing now is we're bringing the same concept of plug and play to the IoT world with IoT plug and play, which is available now as an updated preview today. It's a preview that's primarily targeted for developers to get ready for the launch and the general availability later this year. So with IoT plug and play, there's a number of benefits that come with it. First of all, for solution developers, as I already mentioned, it dramatically reduces their effort to stand up a solution and go to production, because they don't need to get involved into building software on devices. They can just plug the right devices into their solution. For all our customers and partners, this offers a great opportunity to build a large ecosystem of devices and solutions that kind of match each other and can be used across different device types and different solution offerings. And then last but not least, for device providers, it offers the opportunity to certify their devices with us for IoT plug and play, so that they can then go into our catalog and be advertised as IoT plug-and-play enabled devices that will work with IoT Central, that will work with third-party partner solutions that are IoT plug-and-play aware. And the best thing of all of this, with IoT plug-and-play, devices are also already ready to plug into kind of the new ecosystem of connected environments with Azure Digital Twins, because we're using the same language to describe those devices.
So Stefan, let me ask you this question. So we're talking about establishing a convention between a device and a solution, basically with IoT plug and play, right? So we are enabling these developers to have their devices and solutions talk together seamlessly. This is something that I'm curious to know, is potentially supported by open source projects and standards. So tell me a bit about, how we are approaching that world of open source and standards when it comes to IoT plug and play.
Yeah, that's a great question, and yeah, funny you should ask. The technology is all based on open source and open standards. So we're using the DTDL language, the digital twins definition language that we're already using in the Azure Digital Twin preview for describing connected environments. We're using the same language to describe plug and play enabled devices. So all these things will work seamlessly together. And then also, the way we are approaching this on kind of the software side, on the device, and on the solution side, all our SDKs are obviously open source, and we're also documenting ways how to enable IoT plug and play for your devices and your solutions without using our SDKs. If you're using your own custom SDK, or you are kind of a bare metal low level developer, you can do IoT plug and play as well, and we'll have great tutorials for you to learn about that. And so with the modeling language, we describe our device capability model, using a JSON-LD schema. And so this describes the telemetry, the properties, and the commands that the device supports, so that the solution now knows exactly what to expect from the device and how to interact with the device. And so in kind of a very very much simplified view, how the concept works for an IoT plug and play device, when it boots up and connects, it basically, as part of the connection message, it sends an ID across that uniquely identifies that capability model, and so now a solution in the cloud, whether that's IoT Central or an ISV application or partner solution, can now receive that ID, make a determination based on that. It can actually resolve the complete model based on that ID, and parse the model, completely understand all the details about the device, and it can then automatically generate dashboards, for example, for telemetry coming in. But it can also, offer, UX or other means for the solution operator to, send commands to the device, or do other kind of command and control scenarios. And then, the device, will happily, respond to those commands and operations, because everyone kind of agrees on that same convention that is described in the model that is being exchanged from the device to the solution. And that's really it in a nutshell. And so the way it kind of works in more detail, we can look at in a couple of demos that I brought today.
Awesome.
We can connect a couple of devices and write some code and see how it goes.
I love it. And while we're running through the demos, we'll actually point at some of the new things that we have for developers in that preview refresh, right? So let's jump into the demo. The floor is yours. I'm going to interrupt you for sure to ask you some questions here and there. I think we're starting with something which is more a hello world type of thing. things for plug and play, right?
Yeah, let's do our first demo. So here I have an STM32 Discovery Kit, really nice dev board to learn about better development, IoT development, all sorts of things you can learn from there. So let me unbox it real quick. Okay, so I'll connect it to my PC. Now I want to build a IoT plug and play enabled firmware, flash it on the device, and then connect it to my backend solution. So let's see how easy is this with the latest preview of IoT plug and play that we're releasing today. So for an MCU type device, I first want to make a choice about an RTOS that I want to put on this device. For this demo, I'm choosing the Azure RTOS. This is Microsoft, latest and smallest operating system that we've released earlier this year. IoT plug and play is not limited to using Microsoft operating systems, though. You can use plug and play with free RTOS or any other operating system technology on your devices. For the demo, I'm going to use the Getting Started guide for Azure RTOS, and we have a great guide here for this particular dev board that I have. And so this is really easy way to get started. And so I've already cloned the repo here, and so I've loaded up the code here that comes from GitHub. That includes the Azure RTOS as well as the device application that exercises some of the functionality of the device, only a small subset actually. So one thing I want to point out in this demo is how easy we've made it to take a device that doesn't know anything about plug and play and turn it into an IoT plug and play enabled device. And these Getting Started guides are really a good example because we've created them a couple of months ago, before we finalized the conventions about IoT plug and play. So all this code was written without IoT plug and play in mind. And so now, it's very easy to add IoT plug and play here. So the first thing I need to do is, I need to define my model, and I can use this very conveniently in Visual Studio Code or in Visual Studio. We have IntelliSense support for both of these. So as I type these models, I actually get pretty rich support here to help me stay in the syntax and write a proper DTDL document.
So that's you were saying, Stefan, that this is JSON LD, right? So this is something that is JSON and that developers certainly are familiar with, but the addition of the extension with IntelliSense is proper to the DTDL language itself, right? So it's gonna do syntax highlighting and corrections based on and suggestions based on the DTDL specification, right?
Yeah, that is correct. Yeah. And that is provided by an extension that you can download from the Visual Studio Marketplace. Okay. That's about the DTDL specifics. So I've already authored this model file. Really basic. It has a property to give me the LED state. It has telemetry to report the temperature sensor, and it has a command to kind of set the LED state on and off, and I also can control the telemetry interval with a writable property. So that's really it. So this describes what the device already does. So in this case, I'm not starting from an empty implementation. I'm starting from a non plug and play enabled implementation and describe that. And so now if I go back to my code, what I want to do here is I add the ID for my model. This is the ID that I've specified in my model, and now I'm gonna pass this in when I connect or I create my MQTT connection. So I'll pass this in.
So let me ask you real quick. In the code, that's C code, right? And that's for the STM board that you're working on. What now? Are you using the SDK not, or are you? So what is it you're using exactly? Is C files MQTT.h and .c? Is it something that actually allows you to just use the MQTT protocol directly?
Yeah, great question. Actually, you've already stealing my thunder here. So, and yeah, let me answer your question in a second. I'm just kicking off the build here because that'll take a minute. And so while that's building, I'll answer that question. So yes, I think it's an excellent question. So what actually happens to the model ID that I'm passing in here? So if we drill into the lower level code here, actually here's the MQTT create function that takes the model ID, and so if we trace this guy further down here, we're actually getting into the MQTT connect, and so here this string actually surfaces, and it gets appended to the MQTT username that we're then sending out, with the MQTT connect package. And so this is important to know for folks who may not be using our SDKs today, who have maybe created their own SDKs, or doing kind of a bare metal implementation on their devices. They can participate in IoT plug and play just the same way, just by doing the same thing that our code here in this getting started guide does. And we actually have a great tutorial that shows how to do that. For everyone else, using our SDKs, is the easiest and most robust and reliable way to do it. And it's very easy. You just pass in the ID as you create your device client in the SDK, and that will announce your model ID to the cloud.
And beyond the model ID, so the way devices will actually respect the convention of plug and play will be leveraging features from that connection and communication with Azure IoT in device twin synchronization, sending telemetry, receiving commands that developers already implement, right? When they connect to Azure IoT Hub, they are basically supporting these features for having a rich communication between devices and Azure IoT. And so basically what plug and play is doing, and correct me if I'm saying it wrong, but my understanding is that we're using device twin synchronization, send telemetry, receive commands in order to implement the plug and play capabilities, correct?
Yeah, that's correct.
Cool. So if developers have devices already doing all of that, you're saying that adding the model ID and having the implementation of these device twin synchronization, send telemetry, and receive commands being aligned with the naming and so on that are in the model description, then you're good to go. So there should not be a lot of work to be done on the device development side of things, right?
Yeah, that's right. Yeah, if you already have devices today that do telemetry, that do properties, commands, it's a very incremental effort. In many cases, it may just be announcing the model ID. Then what you want to do is do testing to make sure what you've declared as the model actually matches what you're sending, right? That's very important. So we have tools that allow you to do this kind of testing. And then also as a next step, once you get into the certification of your device, we will further help you make sure your device actually complies with the convention precisely with what you've declared in your model.
Awesome. There's
So yeah,
device flashed?
Yeah, device is finished, and I flashed the device, by copying the bin file over to the D drive, which is where my device is at. And so yeah, actually, let's look at the testing part here. So I have the Azure IoT Explorer here, and we've just released a new version of the IoT Explorer that has some additional capabilities that help you test for the IoT plug and play convention to make sure all your devices really work well. And so here you see the first one is actually my STM device. It says it's connected, so that's good news. So here I can go ahead and explore my model and explore all the different properties, telemetry and commands, and exercise the device. So for example, we've added this set LED state command. I'm not sure if we can see this on the screen. So if I send this device this command, the LED turns on, and if I send the false command, it turns off. So hopefully folks were able to see that. So this is how you can interact with your device very easily, test out all the different capabilities in your model and make sure things work.
Something interesting, Stefan, in what we just seen is that the Azure IoT Explorer didn't know anything about the device before it got connected, and that's where the plug and play aspects of things are coming in. Because now in the UI, you have an ability to send a command, and the command is a certain type, which is a Boolean here. So the UI of IoT Explorer adapted to the type of command and was able actually to deliver that in that user experience, so that you can imagine this is just a dev tool here for you to test things around and so on, but you can implement the same thing in your solutions, having a dynamic UX that adapts to the different types of devices that are going to connect in the future to your solution, right?
Yes, very good point. And yeah, you are right indeed. So as you've seen, the device only sends the ID here to the cloud, but the IoT Explorer is then able, based on the ID, to fully resolve the model. And this is the model that we have authored for this device, and now it can apply our model parser, which is another SDK we are making available as part of this refresh release. With that model parser, they can easily make sense of the model files and understand, what are all the commands, what are all the properties, what are the types that go with the requests and responses, and then based on that, they can build dynamically, rich UI that really match the device. And so actually that's a good segue. So let me move on to from the testing phase to let's say I put my device in production and I connect it to a solution. So I actually have a demo solution here that I've built with my friends at Contoso. So it's a device explorer that uses our SDKs on the solution side to receive the model ID, resolve it, parse it, and then make some smart decisions based on this. So here you can see the device has been recognized, with the ID. And so I can drill into the model files that come with this device. So I've resolved the ID to the actual content, and now I can actually build, as you suggested, I can build some UX based on what my model describes. So my model describes some properties about the device here. There's some telemetry for temperature. It's a really warm day today. Let me see if I can put this ice pack on my device.
That's funny. In the winter, you would have actually put you would have blown on it or put your hands to get it hotter, right?
Exactly. So let's see. So we don't see just a flat line here. So yeah, we'll see it moving a little bit. So yeah, my ice pack is already melting here, but it does its job slightly. And yeah, and then I can go ahead and interact with my LED. Now you can't see it because it's under the ice pack, but the LED turns on and off. And so this is all functionality that the Contoso application has discovered dynamically based on what my STM32 device announced during the connection. So yeah, so that's demo number one.
So in a nutshell, so device developer uses IoT plug and play, implements the convention defined in his model ID, in his model that he described in using DTDL, exports that model for a solution builder to get it. In the development stages, so he implements plug and play capability, sends the model ID from the device. We'll test that using IoT Explorer as a tool to make sure that everything works well. And the solution developers on his side will just like get things, working, right?
Yeah, exactly. So yeah, that's a really good summary. Yeah. So the solution developer, doesn't really need to know about any of the internals of the device. All they, get is the model ID, and then they can, make decision based on that. In some cases, they may just, look at the model ID and they know what to do, or they actually go resolve it, parse it, and then dynamically reflect over that content and do smart things based on that.
And so when we think about IoT solutions in general, it's not just about microcontroller devices, right? You have a variety of types of devices out there you want to connect. So what can plug and play actually be used beyond these sensor, tiny MCU-based devices?
Yeah, absolutely. Yeah, you can use it with any type of device, with any type of operating system, any type of programming language, any type of IDE, where we want to meet the device builders where they are today. We're not imposing Visual Studio or particular SDK or operating system on them. Whether they use Linux or they use FreeRTOS or Azure RTOS or Windows. All are great options for devices to implement IoT plug and play capabilities.
Well, and as a matter of fact, we deliver all of that, as you mentioned, like open source, all the SDKs, all the sources, even DTDL language itself is an open source project as well. Make people's life easier. So let's see the next step of your demo where you connect another type of device with plug and play.
Yeah. What do you want to do? Do you have a toaster that we can connect or something?
Fridge, or we're talking a lot about consumer devices. The basic one actually could be very interesting in development as well. Is a mobile phone. Could be part of a scenario for your plug and play, for your IoT solution in general, as a companion or as a contributor in terms of data and all the sensors that the phone has as well. So. How about a mobile phone?
Yeah, it's a good point. Android is an operating system we actually see quite a bit more in enterprise scenarios now, in mobile scenarios and other scenarios. So yeah, we certainly support Android, and you can IoT plug and play enable your Android device with our SDKs. And so why don't we just do it? So I have my Android device here. So let me unlock this, and let's see how we can do something interesting with IoT plug and play here. So let me switch over now to Android Studio. So with Android, there's a couple of options as a developer. You could do, Xamarin development if you're .NET guy, or you can do Java development, Kotlin, a couple of other choices as well. I think the most common probably is doing Java in Android Studio. So that's what I want to do here. So I've loaded up Android Studio here with a basic sample that we've actually released a couple of years ago. I believe 2 years ago. So this is not an IoT plug and play sample. It's just a general Azure IoT sample for Android. And what I want to do now is turn this into IoT plug and play and implement some interesting capabilities that would make sense on a mobile device like this one. So specifically, I want to turn this into an asset tracker. So first step again is I'll go write my model file that describes my asset tracker, and so it's really kind of two pieces here that I want to implement. One is I want to implement telemetry for location, so I know where my asset is located. So I describe this telemetry as the semantic type location. This is some additional information that's useful for a solution, so that it knows those are not just numbers. Those are actually, they have a specific semantic meaning. And then, actually, I don't need this guy. And the second thing I want to implement is a command to send voice messages to the operator that's operating that mobile device right now. And then last but not least, I'm also sending my standard sort of device information to the cloud, so the cloud knows what type of device this is. This is an optional thing that device builders can include in their firmware. It's not mandatory, but it's a useful thing for solutions to know about standard info about your device. So this is my model, and now I want to go ahead and in my Android application, I will announce this model. So I set the model ID in my creation options here. So this is the ID that for the model I just created. So second thing I need to do is actually send the location telemetry. So this is my loop here, where I, obtain the location and then push it out to the cloud as telemetry. And now the third part I need to implement is my command. So here's the command callback, where I can switch over, different names. And so we've defined the command speak to actually speak. And so let me see what happens if I put this on my phone and then see how it works. So this would take a minute.
And while it's doing that, so there's an interesting thing that that actually you just demoed, which is the device already had an application doing a bunch of things, sending telemetry and things that have been developed in the past. You basically just described the model based on what the device application was already doing, sending telemetry, receiving a command, and you just added a model ID into your connection stream. But that's it on the developer side of things. On the device developer side of things, if you already had a device that was using device twins and telemetry and commands or direct methods from Azure IoT Hub, actually you're already set, right?
Yeah, that is right. Yeah. I mean, in this particular case, I added these two things, right? I mean, the speak functionality that wasn't part of the original sample, as well as the location telemetry. But yeah, the general point definitely is true. If you're already doing these things, you can just describe it. If you want to, add more functionality over time. You add that to your model and implement it on the device. And we'll actually see that in a second as well. How we can go in kind of an inner loop scenario and sort of iterate on that model. So let's see. Device is now running the application, and let's see. So if I switch back to my Contoso application here, you can see my device shows up here. I can actually inspect my model. It's this model that I just authored. So we were able to resolve that. And so if I look into the detailed view here, what I'm doing here is, parse the model. And so here you can see it's reporting the telemetry, every couple of seconds, and when it snaps back to the center about the position of the asset. So let's see if the voice command works as well. And so let's see if our folks can hear this if I send this to the device.
IoT show rocks. IoT show rocks. IoT show rocks. End of message.
All right, system works. So that's IoT plug and play enabled Android device. With just a couple of lines of code, and we're ready to roll.
That's awesome.
So one thing I want to add here, and this is kind of goes to your previous question. So what during my inner loop, I find, hey, I'm really missing some key functionality here that I want to add to my device, and so now what I want to do is go back to my model file. And let's say I think I need another command here so that I can remotely reboot my device. So I'm adding a second command here that takes another parameter to kind of delay the reboot by specified amount of seconds. And so I save this off. And now if I go back here and load this again, my parser should kick in again. And so now it shows the extra command here. So it's all dynamically created. And so I can go ahead and send this command now. And now obviously I haven't implemented it yet, but my breakpoint hits here. And as you can see, the method name, method name is reboot. So this really makes it easy. Now I know, okay, I just need to add another case statement here, to facilitate this new command and then trigger the reboot of my device. So this, sort of dynamic nature of the development model is really nice, during inner loop, and you don't have that tight coupling between the solution and the device. It all kind of is driven by the model. You just change the model and then you're good to go.
So you've been using a phone to demonstrate a type of device. Could have been a point of sale or another type of device like that. But like simulations as well is something super important in your development cycles. And I'm wondering, so we have these SDKs with tons of samples. Is it a good practice to spin off a simulator as a solution developer that's going to help you, develop your solution and also eventually test situations that your devices might not be in immediately, but there are extreme cases, and you can actually force telemetry to go in like super high temperature and trigger things that might not be triggered in nominal functionality of your devices.
Yeah, definitely. Simulated devices I think are very important in the development process, especially if you are a solution developer. You don't want to get too deeply involved in embedded device development and ramp up on all that. So you can use our SDKs and build simulated devices that match the model that your solution is interested in. And we provide, a number of samples for that, across the entire spectrum of programming languages. We have, Java, we have C#, we have Node, Python, C, you name it. And, you can run those on your development machine. You can run those on your Windows PC, on your Linux PC, or on your Mac device. And those are, actual devices, right? We always say simulated devices. I mean, they are simulated in the sense that they are not really reporting, true sensor data, but everything else about them is, using the exact same stack as a actual device would be using on that operating system, whether that's Windows or Linux or Mac.
So cool, Stefan. So we can definitely simulate using any language of choice. If you're a Python guy, if you're a Java guy, so you have everything there. Stefan, before we let everyone go, how about IoT Central? Little word about that.
So as we said earlier, with IoT Plug and Play, we're really eliminating the tight coupling between the device and solution. So now that I have IoT Plug and Play enabled, my Android device or my STM32 device or whatever I've done, I can not only run it against my Contoso application as we've shown, but I can also run it against my Fabricam application or the Azure IoT Central application or any other third-party partner ISV application out there, that is aware of IoT Plug and Play. So actually, let me show this here real quick before we move on from the Android one. So I've already prepared that, and so I have a switch here that kind of changes my credentials over to connect to an instance of IoT Central instead. And so I'll deploy this to my phone, and so now it's running. Let me switch over to IoT Central here, and IoT Central says, okay, there's updates available. So let's drill into my asset tracker here. See, it shows my location here. And we have all the device information that the device sends, and I can go ahead and send my speak command to the Android device here. So same functionality. Central is able to discover it dynamically just as well as the Contoso application is. And so now my asset tracker, I can now use it with any IoT plug and play solution out there.
Great demo, Stefan. So we have a short link for people to learn more about IoT Plug and Play. It's aka.ms/IoT show/IoT Plug and Play, all spelled out. What else do you want developers to do, Stefan?
Yeah, really want to call all device builders, that now is the time to go to this link. Check out our documentation, samples, and SDK. With this preview release that's available today, you have everything you need to get your devices ready for final certification. We'll open up the certification process in just a few weeks, and that'll give you the opportunity to be ready ahead of time for the launch and generally and globally availability later this year. Same call also goes out to solution developers. Go check out our SDKs and our documentation and samples, and get your solutions ready for these IoT plug and play enabled devices.
Awesome, Stefan. Great demos, great presentation. Everyone, you know what you have to do now. Go check out IoT Plug and Play and get started on making your application seamlessly integrate devices. Stefan, hope to see you soon on the show. Everyone, thanks for watching. Do not forget to subscribe. See you soon. Bye.
Thanks, Olivier. Bye.